In this video, I'm going to talk about convex lens ray diagrams and the lens equation for real images. So in this diagram, I'm going to place a focal point here at about 5 centimeters, and on the other side as well at 5 centimeters. And recall that distance is measured with respect to the center of the lens. Then I'm going to put an object over here at approximately 5, 10, 15 centimeters. So it's outside the focal point. And I want to do two things. I want to draw the lens ray diagram. To locate the image. And I want to quantitatively calculate where the image is. So for the lens ray diagram, again, I draw two rays. I'm going to draw one ray that's parallel to the principal axis, and I'm going to draw the line parallel across here and to the center of the lens, making sure it's parallel. And as we saw in class, we want to make sure that this distance is the same as that distance to ensure that it's parallel to the principal axis. Then we're going to draw this right to the focal point, right about there. Then we're going to draw a second line that goes to the center of the lens. So it's going to be angled this way and come down and hit. So it's going to go down here. So I can draw that down there like this, the center point, like so. So where those two lines intersect is where the image is. And so it looks like it's upside down. Should be right around there. It's upside down. And it looks a little bit smaller than the original. So we're going to calculate where that's at. So quantitatively, we're going to list the equation, so it's a lens equation, which again you do not need to memorize. It's on the equation sheet. Then we're going to list the variables. So we know that f is equal to 5 centimeters. DO is, in this case, 15 centimeters outside the focal point. Always measure it with respect to the center of the lens. And DI we need to find. So in the solution part, or the solve part, we're going to break it down to 5 mini steps here. A, B, C, D, and E to make sure we don't forget anything. So this is 1 over F equals 1 over D0 plus 1 over DI, which is 1 over 5 equals 1 over 15 plus 1 over DI. This is 0.2. 1 over 15 is 0.066 repeating. I'll put a 7 there, plus 1 over DI. If you subtract 0.06 from both sides, I get 0.133 equals 1 over DI. And again, I don't want 1 over DI, I want DI. So if I invert or cross multiply, invert multiply, DI is equal to 1 divided by 0.133, which is, according to my calculation, about 7.5. Since we're in centimeters, this is going to be centimeters. We box our answer. So what this means is that my image is located at 7.5 centimeters. So if my focal length is 5, right here, this is about 6, 7.5. If you draw this to scale and measure, it should be exactly at 7.5 centimeters. And we get a positive answer, which implies a real image. So those are the steps you need to follow to draw a convex lens ray diagram and use the lens equation for real images.